Hari Om. Hello everyone, I'm Sri Jyoti. Welcome back to my channel. Today's video is of class 12 mathematics chapter 10 vectors. In our small classes we have already learnt about vector quantities. For example, displacement, force, velocity, acceleration, etc. are vector quantities, right? That is, vector quantity is a quantity having both magnitude and the direction, right? Say we know that acceleration is a vector quantity, right? So here in acceleration, vector represents the rate of change of velocity, right? For example, if a car increases its speed from 20 meter per second to 40 meter per second in 5 seconds, okay, this acceleration vector is calculated and expressed in terms of magnitude and the direction, right? That is, vector is a quantity having both magnitude and direction. We know that what is a scalar quantity. This one also we studied, right? Scalar quantity is a quantity having only magnitude. There is no direction. For example, time, distance, volume. These are scalar quantities, right? So there is no direction. So here we will study only vectors. Okay. So vector is a quantity having both magnitude and the direction. And vectors can be represented by directed line segment. Vectors can be represented by directed line segment. What is a directed line segment? A line segment with one of these directions is called a directed line segment. Okay, and vectors can be represented by directed line segment. And here we know that there are 2 points. First, a starting point and ending point, right? So here the point from where vector starts is called the initial point, and where it ends is called the terminal points. Okay, the point from where vector starts is called the initial point, and where it ends is called the terminal point. That is, starting point is initial point and ending point is terminal point. Okay, and the distance between them, that is, distance between initial point and the terminal point is called magnitude of the vector. So what is the magnitude here? Magnitude of the vector. That is nothing but length of the line. Okay, that is, distance between initial point and the terminal point is called magnitude of the vector. Here that is length of the line. Okay. And here direction can be indicated by arrow, okay, pointing from initial point to terminal point. Okay, that is direction of the vector indicated by an arrow pointing from initial point to terminal point. Say it's a vector. Okay, let's take it's a vector from A to B. Okay, that is initial point is A and terminal point is B. So it's a vector which direction? In this direction, right? So here we write the vector from A to B is written as vector AB. Here A is initial point and B is terminal point, and the vector from A to B is written as vector AB. Or if we say it's a vector A, then it is this also we can write. Okay, we can write vector small a. Okay, so here that is length of the vector or magnitude of the vector can be written as modulus of vector AB. So remember, modulus of a vector is nothing but it shows that it represents magnitude of the vector. Okay, that is modulus of the vector AB is it represents the magnitude of the vector A. Okay, or we can write, if it is vector A, then modulus of the vector A is, magnitude of the vector A is written as modulus of vector A. Okay. Next is position vector. See, we have a XYZ plane. Let's consider a point in XYZ plane P of x, y, z. Okay, we have considered a point P of x, y, z in this plane, x, y, z plane. Okay, here it is the origin O of 0, 0, 0. It is the origin. And the vector OP is called position vector of point P with respect to the origin. Okay, this vector OP is called position vector of the point P with respect to the origin. Okay, that, and it is also denoted by vector R. Okay, vector R, position vector, vector R. And here, what is the magnitude of the vector OP? That is nothing but distance between 0 and P. Right? Magnitude of the vector OP or magnitude of the vector R is nothing but distance from 0 to P. Right? So, it is denoted as vector, modulus vector OP. Magnitude of the OP is written as modulus of vector OP. That is equal to modulus of vector R. That is magnitude of the vector R. That is equal to, how to find? By distance formula. Using distance formula, here we will find what is the magnitude of the vector OP. Okay. So, what is the distance formula? Distance from 0 to P, that is nothing but square root of x minus 0, x minus 0. That is, if it is x1, y1, z1, x2, y2, z2, we know that x1 minus x2 whole square plus y2 minus y2, y1 whole square plus z2 minus z1 whole square, right? So, here x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square, right? It is the distance between 0 and P, right? So, here magnitude of the vector OP, that is equal to magnitude of vector R, that is equal to x, using distance formula, square root of x square plus y square plus z square. Okay, that is modulus of R, that is magnitude of the position vector, magnitude of the position vector, position vector R is equal to square root of x square plus y square plus z square. Okay. Next is direction cosines of a vector. Very important. Direction cosines of a vector. We have x, y, z plane. And let's consider any point on this plane P of x, y, z. Any point other than origin. Okay. So, it is the origin O 0, 0, 0. Okay. So, here we know that this vector is the position vector. Position vector R. Okay. And here this position vector makes three angles. Alpha, beta, gamma with the positive direction of x-axis, y-axis and z-axis. Okay, this position vector makes three angles alpha, beta, gamma with the positive direction of this axis, x, y, z axis. Okay, and here these angles are called direction angles. Okay, and the cosine value of these angles, that is cosine value of these angles are called direction cosines of a vector, that is position vector. Direction cosines of a position vector, vector R or vector OP. It is written as the cos alpha, cos beta, cos gamma are direction cosines of a vector. Okay, and here direction cosines of a vector are usually denoted by L, M, N. That is, L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. These cos alpha or L, M, N are the direction cosines of a vector. Here cosines of a vector, position vector. Okay, direction cosines of a position vector, vector R. Okay, and here we can make right angle triangles. Okay, that is See, let's take it is A, B, C. We can make the right angle triangle O, it is O, right? Okay, it is O. O, A, P with right angle at A. Okay, that is a triangle OAP right angled at A. Separately I will draw, that is here it is A. Okay, it is R, sorry, P, it is O. Okay, now here the angle is alpha. Okay, and it is the right angle triangle, that is AOP right angled at A. That means that angle of A is 90 degree. Okay, so here in this we can write this cos alpha is equal to, what is cos alpha? Adjacent divided by hypotenuse, right? So this hypotenuse is nothing but it is the vector OP, right? That is R. Okay, here it is R, this distance is R, vector R. Okay, and its magnitude, that is modulus R, or we can write it is R. Okay, here R is magnitude of the vector, this vector OP. And see, it is nothing but X, that is distance of this one, it is X, it is Y, it is Z. Okay, then here cos alpha is equal to adjacent divided by opposite, that is X divided by R. Okay, then next, see, let's consider this triangle, that is OBP. Okay, here in triangle OBP right angled at B. Okay, so here next triangle OBP, okay, OBP right angled at B, that means angle of B is 90 degree. Here also it is this OB length is nothing but Y. Okay, and it is R. Therefore here the angle is beta. Okay, for this angle. Okay, that is cos beta is equal to, here we can make this right angle triangles. Okay, so cos beta is equal to adjacent divided by hypotenuse, that is Y by R. Y divided by R. So here we cannot draw this right angle triangle, that is why drawn separately. Okay, so next triangle, right angle triangle OCP, triangle OCP right angled at C. Okay, right angled at C, OCP. Here what is the length of OC? That is Z. Okay, the length of OC is, because that is this point, okay, P of X, Y, Z. Therefore, this length is X and it is Y and it is Z. Okay, so here it is the length distance Z and it is R. So what is, it is the angle gamma. Okay, for this angle we have made the right angle triangle OCP right angled at C. Okay, in this triangle we can write cos gamma is equal to Z divided by R. Okay, cos gamma is equal to adjacent divided by hypotenuse, therefore Z divided by R. Okay, so we have got cos alpha is equal to X by R. Here what is R? See, here R is nothing but modulus of vector R. See, it is the position vector, right? It is the position vector, vector R. And here R is nothing but magnitude, that is distance of this position vector. Okay, that is modulus of vector R, magnitude of the vector. Okay, so here now we can write this cos square alpha plus cos square beta plus cos square gamma, that is equal to x square by r square plus y square by r square plus z square by r square, that is equal to x square plus y square plus z square divided by r square. See, what is x square plus y square plus z square? Here we know that what is the magnitude of the vector r? So just before we have found, right, that is modulus of vector r is equal to square root of x square plus y square plus z square. Square it, that is r square, right? r square is equal to x square plus y square plus z square. Here modulus of vector r is r, that is equal to r, right? So that is equal to, so x square, that is equal to x square plus y square plus z square. That is, this x square plus y square plus z square is equal to r square divided by r square, so is equal to 1. See, we have got cos square alpha plus cos square beta plus cos square gamma, that is equal to 1. Here cos alpha, cos beta, cos gamma are the direction cosines of a position vector r. Okay, and or we can write, see, cos alpha is nothing but L, right? It is denoted as L. So L square plus m square plus n square is equal to 1. Very important result. L square plus m square plus n square is equal to 1. Here L, m, n are the direction cosines of a vector. Okay. So note it down. If L, m, n are the direction cosines of a vector, then L square plus m square plus n square is equal to 1. Very important. If L, m, n are direction cosines of a vector, then L square plus m square plus n square is equal to 1. Direction ratios of a vector. In xyz plane, P is any point, P of xyz, and vector OP is the position vector. Here the coordinates of P can also be written as, see, here we know that x is equal to LR. Why? Because in our last topic, that is direction cosines of a vector, we have already given L is equal to cos alpha, right? And we know that cos alpha is equal to x by r. Say, right? So from this we can write x is equal to LR. And similarly y is equal to mr and z is equal to nr, right? Therefore the coordinates of P are LR, mr, nr. Okay. So these coordinates are called direction ratios. That is, the numbers proportional to the direction cosines of a vector are called direction ratios of vector. And direction ratios of a vector are usually denoted as A, B, C. And here we can write A square plus B square plus C square is equal to LR square plus MR whole square plus NR whole square. That is L square R square plus M square R square plus N square R square. Here R square is common, take R square outside. So L square plus M square plus N square. Here it is equal to 1, right? It is equal to R square. So A square plus B square plus C square is equal to R square. A, B, C are the direction ratios of a vector, position vector R. Next we are going to study types of vectors. First one, zero vector. A vector which has magnitude 0 is called a zero vector. Okay, a vector having zero magnitude, magnitude is 0, is called a zero vector or null vector, and it is denoted as vector 0. Okay, next is unit vector. Unit vector. A vector which has magnitude 1 is called a unit vector. Okay, a vector which has magnitude 1 is called a unit vector, and unit vector of vector A is denoted by A cap. Read as A cap. Okay. Next is co-initial vectors. Co-initial vectors. That is, vectors having same initial point are called co-initial vectors. See, here it is vector A, it is vector B, it is vector C. Here initial point is same for these three vectors, right? That is, vectors having same initial point are called co-initial vectors. Therefore, vector A, vector B, vector C are co-initial vectors. Okay. Next is collinear vectors. Collinear vectors, two or more vectors are said to be collinear. if they are parallel to the same line. We studied collinear points. That means if 3 points are lying in the same line, then we say these are collinear points, right? Here also 2 or more vectors parallel to the same line are called collinear vectors. Okay. So next is equal vectors. Equal vectors. Okay, two vectors, vector A and vector B, are said to be equal vectors. Then equal vectors if they have magnitude, same magnitude and same direction. Okay, if two vectors have same magnitude and same direction, then these two vectors are equal vectors. Okay, these two equal vectors are said to be equal vectors. Okay. Next is negative vector. Negative vector. See here vector AB. Okay, vector AB. Vector AB. See, we know that vector AB and it is vector BA. Okay, BA. Here, see here magnitude of vector AB and vector BA are equal. Right? Magnitudes of vector AB is equal to magnitude of vector AB is equal to magnitude of vector BA. But their direction is opposite, right? So here we can write that is vector BA is the negative vector of vector AB. Okay? Its magnitude is same but opposite direction is opposite. Okay, that means here we can write vector AB is equal to minus vector BA. Okay. Next is coplanar vectors. 3 or more vectors are lying in the same plane or parallel to the same plane are called coplanar vectors. That is, if 2 or 3 or more vectors lying in the same plane or parallel to the same plane, then we say these vectors are coplanar vectors. Now let's go through exercise 10.1. First question, represent graphically a displacement of 40 km 30 degree east of north. See, it is given the quantity displacement represented as magnitude with direction, right? That is vector quantity. Okay. So here first of all let's represent directions east, west, south, north, and it is given 30 degree east of north. See, it is the 30 degree east of north, and let's take it is the point B and O. This distance is nothing but 40 km. Okay, that is here vector OP is the required displacement of 40 km and direction 30 degree east of north. That's all. So here vector OP is the required displacement of 40 km with the direction 30 degree east of north. Second question is classify the following measures as scalars and vectors. Right. See here 10 kg, that is mass, right? 10 kg, here no direction, therefore it is scalar. And so what is the quantity? This one 2 meters northwest, that is displacement, right? So here it is mentioned, direction is mentioned, right? So it is displacement, therefore it is vector. Next is 40 degree, that is angle measure, degree measure, right? So it is scalar. And 40 watt, that is power, quantity power, that is scalar, right? There is no direction. Okay. Then 10 raised to minus 19 coulomb, that is charge. Okay, quantity charge, it's also scalar. There is no direction. And here, see what is 20 meter per second square? Acceleration, right? Acceleration is vector quantity. Okay, so it is vector quantity. Classify the following as scalar and vector quantities. Here quantities are given. Time period, obviously it is scalar, right? Scalar quantity. distance, scalar, right? Then force is vector quantity. And what about velocity? It's also vector quantity. And work done, that is scalar quantity. There is no direction. Okay. So work done is scalar quantity. In the figure, a square, identify the following vectors. Here it's a square, okay, and it is given vector A, vector B, vector C in this direction, vector D this direction, okay. So here we have to identify co-initial vectors. Co-initial, equal vectors, collinear but not equal vectors, okay. So here first of all, co-initial vectors. Co-initial vectors having same initial point, right? So here we can see that, see, vector A and vector D have same initial point, right? Vector A and vector D have same initial point. Therefore, here vector A and vector D are co-initial vectors. Okay. Next is equal vectors. Equal vectors having same magnitude and same direction, right? Here magnitude are same for all the vectors, right? So because it's a square, okay. And direction, see, here vector B and vector D have the same direction, right? This direction, right? So vector B and vector D are equal vectors, same magnitude and same direction. So vector B and vector D are equal vectors. Okay, next is collinear but not equal. Collinear vectors are parallel, right? Parallel vectors, and here irrespective of magnitude and direction. And see, here vector A and vector C are parallel vectors and they are not equal. See here, B and D are collinear vectors, okay? B and D are collinear vectors but they are equal. It is given collinear vectors but not equal vectors, okay? So here vector A and vector C are collinear vectors but not equal vectors, okay? But here B and D are collinear vectors and equal vectors, okay? So here answer is vector A and vector C are collinear but not equal, okay? Answer the following as true or false. Vector A and minus vector A are collinear. We know that vector A and minus vector A are parallel to the same line. Therefore, vector A and minus vector A are collinear is true. Two collinear vectors are always equal in magnitude. That is false, right? Because, for example, vector A and vector 4A. Vector A and vector 4A are parallel to the same line, but their magnitudes are different. Magnitudes are not equal, okay? Therefore, two collinear vectors are always equal in magnitude is false. Next, two vectors having the same magnitude are collinear. See, we know that unit vectors having magnitude 1, that is same magnitude, right? So here unit vectors along a different coordinate axis having same magnitude but they are not collinear, okay? Therefore, it is also false. Two collinear vectors having the same magnitude and are equal. Two collinear vectors having the same magnitude and are equal. See here, two collinear vectors, see vector A and minus vector A are collinear vectors, right? But they are not equal. Okay, they have same magnitude but their direction is not equal, right? Therefore, here it's also false. Okay, example, vector A and minus vector A are collinear vectors but their magnitudes are same but direction is not same, okay? Therefore, they are not equal vectors, okay? Vector A and minus vector A are not equal vectors. Therefore, this statement is also false.